The electron configurations determine the chemical properties of elements, but they also provide a way of dividing the table into 4 blocks of elements with similar properties. Each of the blocks is named for the shapes of the orbitals of the valence electrons. The s block is made up of elements whose valence electrons are in s orbitals only. They are the elements in the first 2 groups on the left-hand side of the table. Group 1 are called the alkali metals, and Group 2 are called the alkaline earth metals. They are soft metals like sodium, potassium, and calcium that react readily in air and water. The s block is only 2 elements wide because s orbitals can only take 2 electrons. The d block elements occupy the middle of the table. These elements are called transition metals. They are strong metals such as titanium, chromium, gold, and iron that make useful building materials. The d block is 10 elements wide because d-shaped orbitals can accommodate 10 electrons. The f block elements are placed below the main body of the periodic table. The 2 periods are 14 elements wide because the f-shaped orbitals can hold 14 electrons. These elements are rarely found and become increasingly unstable the higher the atomic number. The most familiar is uranium, element 92, which is used as fuel in nuclear reactors and atomic bombs. The p block elements are on the right-hand side of the periodic table. These are some of the most common and important elements and include carbon, iodine, oxygen, nitrogen, and sulfur. The p block is 6 elements wide because the p-shaped orbitals can accommodate 6 electrons. Included in the p block are the noble gases at the right-hand side of the table. Because their valence energy levels are full of electrons, the noble gases rarely interact with other elements. Chemists sometimes talk about the elegance of the periodic table, and the reason they see elegance is because the table reflects perfectly the structure of atoms. It remains the most important organizing principle of chemists because it helps us understand the atomic structure of the elements and their chemical reactions.